Thank you for joining me today. We're going to talk about data structures and why they're important for coding jobs. Think about the very words data and structure. They're almost self-explanatory in themselves. It's easy to hear words and then let them pass right by without a thought. And when they come back to us through either questions or everyday language, we think, wow, I have no clue what it even means. In our fast-paced world, it's so crucial to slow down, to think, to analyze, to define, to comprehend. So let's analyze our topic of data structures and attempt to make it easy. When companies interview for developers, it's important for candidates to be able to structure data in their particular way. The way companies process information, or data, and organize it is very important. They want their programmers to be able to know how to handle large amounts of their data in highly organized and efficient ways. And today, we're going to practice handling data by creating a game. That's what data structures are, organizing information. And the classic rock, paper, scissors is the perfect set of waters to get your feet wet without a huge set of information or data to handle. For time's sake, we'll only be covering 3 examples for now, even though there are several ways it could be coded. At the very base level of planning, we start with the possible outcomes of the game. And in rock, paper, scissors, there are only 4 to consider. This is our data that we can organize and store by either implementing a dictionary, using if statements, or creating a matrix by importing NumPy or NumP, depending on how you say that. The easiest solution, and not necessarily the best in my opinion, is to use if statements. It's definitely readable, so you can easily see what's going on. Creating variables for each scenario, including players, makes it very simple. You have 2 players with 4 scenarios, leaving you 6 variables to create. Now, all you're doing is using operators to return results. Starting off with tackling a tie outcome right away is smart, and then figuring out every way player 1 can win next. And finally, just returning everything else, which would be a win for player 2. Our second example uses the dictionary to store our information, or 3 game outcomes. The tie outcome is not in the dictionary, but stored in an if statement. Then, similar to our last slide, it accounts for all wins on player 1's side, and then just returns all other outcomes as it would automatically give the win to player 2. For our final solution, I split it into 2 examples. So let's look at, say, 3.1 first, and then on to 3.2. 3.1 uses a matrix in NumPy under the variable grid. The variable labeled D assigns a number to the 3 game pieces. When players choose their game pieces, it returns a result from the matrix. Let's look at our next slide for a better picture. 3.2 shows us a bit more detail as I wrote some comments to show more information. It's very similar to our last slide, but this matrix is using numbers representing the data. If the result returns a 0 in accordance to the matrix, player 1 wins. And if it's a 1, player 2. And when both players choose the same, a 3 returns a tie. Feel free to pause any of these slides and look over the code. Like I've mentioned in other videos, play around with it in your own IDE and see what works. Or write your own, test your own knowledge. Find a friend to play the game with. Hopefully this video gave you some insight on data structures in the coding world and why they're important. This may just be a game, but in the professional realm, the principles behind it are very similar. Thank you for watching, and I hope this video was helpful to you. Daily videos throughout the week are coming out, so don't forget to subscribe.